Alright, let's look at the homework 16.6, problem number 10. Alright, so we want to find the surface area whose parametric equations are given here. Alright, so I'm going to just go ahead and call this guy R. Alright, so R is going to be, let's say x is u squared, so first component is u squared. Second component is uv, right? And third component is 1/2 v squared, right? Let's find the partial derivative of u, cross product with the partial derivative with respect to v. Alright, so this is going to be, alright, so we're going to have vector I, vector j, vector k. Alright, so we're going to have a partial derivative of this guy with respect to u would be 2u. And partial derivative of uv with respect to u would be v. And partial derivative of 1/2 v squared with respect to u would be 0, because it's a constant. Right? Then partial derivative of u squared with respect to v is 0. Partial derivative of uv with respect to v is u. And the partial derivative of 1/2 v squared with respect to v would be v. Right? So this is going to give us, alright, so here, cross product, so v squared. Alright, and next one is 0 times 0 minus negative 2uv, right? And the last component is 2u squared. Alright, then we want to find the magnitude of this cross product. So magnitude is going to be just square each component, add them up, and then take the square root. So you have a square root of, alright, v squared squared, so v to the 4th power. And let's see, negative 2uv squared would be 4u squared, v squared. And 2u squared squared would be 4u to the 4th. Right? And luckily, we can complete the square inside the square root. This is going to be quantity v squared plus 2u squared, whole quantity squared. So we can cancel square root and the square there. So we end up getting v squared plus 2u squared. Right? So all we have to do is take the double integral, so surface area, so area of this surface, let's call this guy S, right? We need to call something, right? So we have a double integral, right? So we have, then you have a v squared plus 2u squared. With respect to u, then with respect to v, right? U go from 0 to 3, so I'm going to put the 0 and 3 there. And v is going from 0 to 1, 0 to 1, right? So let's evaluate that. So leave the outside integral alone, so I'll leave that. So dv, right, antiderivative with respect to u, so it's going to be v squared times u. Right, antiderivative of that is 2 over 3 u cubed. Right? Then you're going from 0 to 3. Right? So this is going to be equal to, alright, so we still leave this guy alone for now. Alright, so if you plug in 3, so you're going to get 3v squared. And if you put the 3 there, so one of the 3 cancel out, so it's going to be 2 times 9, so it's going to be plus 18, and with respect to v, right? Then we can take the antiderivative, it's going to be v cubed plus 18 v. And v is going from 0 to 1. Right? So if you plug in 1, you get 1 plus 18 times 1 is 18 minus 0. So that's going to be 19. Right? So let's type it in. So we got 19. Right? So let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.